Hey there. So today we're going to be doing 4.1 plot points in a coordinate plane. And what I would like for you to do, pretty please, is fill in the vocabulary on your own for quadrants, coordinate plane, and ordered pair. They will all be found in your books. You can use your glossary for that one. So I do want to tell you though, for the quadrants, we have four of them because of the word quad, four. And there's going to be 1, 2, 3, and 4. Not really intuitive, but just let you have that down for sure. Make sure that if you're looking at this, so this is your coordinate plane, which has an x-axis and a y-axis. You have quadrant 1, quadrant 2, quadrant 3, and quadrant 4, Roman numerals. So each thing will have an ordered pair, and so for your ordered pair, just a couple of highlights. You know that it goes x and y. Your x tells you to go left and right, and your y is your up and down location. So if I would like to, for example, give the coordinates for A, B, and C, I'm looking at A first, and I'm going to write this as always the x comes first, so the movement from left to right. And when you're talking about that movement, you're always going to start at the origin. So I'm going to go over 1, 2, 3 times to the left, and because I went to the left, it's -3. And then from there, I'm going to go up 1, 2, 3, 4. And because I went up, it's going to be a +4. So that's my coordinate for A. For B, you can do the same thing, and you're going to count your spaces. So I'm going to go right 1, 2, 3, it looks like. And because I went right, it's +3. And then from there, I'm going to go up 1, 2, 3. I cannot count on this thing. If this is 10, 9, 8, looks like 8. Check me and count because I think your eyes are probably about 1,000,000 times better than my old eyes. Then for part C, I'm going to count again. 1, 2, 3, 4, 5, looks like. And so that's to the right, so it's 5. And then I'm going to go down 1, 2, 3, 4, 5, 6, 7. So -7. Last one is D, and I'd like for you to figure that one on your own. Just notice that you're going to go left and down, so you should have some negatives for that one. I'll check those when I check your notes. For the next part, they would like for me to plot the points and describe the location. So when they say describe the location, they want you to tell them the quadrant. So for 3, and remember, I like to sometimes, just because sometimes we forget, I like to write this as a coordinate, noting that the x and y is still my left and right, and my y value, my x is up left and right, and my y value is up and down. So for J, I'm going to go 4 to the right and down 3. Always start at the origin. So 1, 2, 3, 4, and down 1, 2, 3. And I'm going to label that one as J. Your next one is K. And oh, I think yours is cut off here, but this is an L. I believe your hole punch got a little bit jacked. For K, I'm going to go left 1, 2, 3, and up 1, 2, 3, 4. Okay. And then for L, 1, 2, 3, 4, and then down 1, 2, 3. Yep, I am pretty much always going to count out loud because it helps me keep track. For M, 1, 2, 3, 4, right 4, and up 1, 2, 3 for M. Just remembering that the first number will still tell you left and right. I like to make sure. Sometimes if you're kind of like looking at me like, what are we doing here? Remember that to the right is positive, so to the left is negative, and then going up is positive, and going down is negative. Left, negative. Sorry to my left-handed people. I'm left-handed, but it always is a negative thing in some places, some real-world applications on that one. So the next one we have is 0, 4. So 0 means I'm not going to go left and I'm not going to go right. Instead, I'm going to stay right at the middle, and I'm just going to go up 1, 2, 3, 4 from there. 1, 2, 3, 4. And I'm going to label that one as in. The labels are kind of important because if you don't label, then I'm probably going to take off a point. And by probably, I mean definitely. So 0, 0, that means I'm not going to go to the left or right or up or down. I'm going to stay right there. Coincidentally, this O for the point 0, 0 is also known as the origin. Origin, O-R-I-G-I-N, origin. So one thing I forgot to do was to, I'm going to change the color, was to say the location also. So here's what we know. This is quadrant 1, 2, 3, and 4. So this point right here, J, is in quadrant 4. K is in quadrant 2. L is in quadrant 3. M is positive and positive, so I know it's quadrant 1. And then N is right on the line, so I'm going to say that it is on the X. Just kidding. So this is your x-axis, and this is your y-axis. I know that looks like an x, but it's actually a y, because it's on the y-axis instead. Love it. So that you do. Next one, graph the function with the given domain, then identify the range of the function. So domain, remember, that's your input values, and so if I were to make an xy table, my domain would be all of these numbers, so -2, -1, 0, 1, and 2. In order to complete this, I would need to plug in each value into my master equation right here. So y equals -3 times -2 plus 4. Then simplifying, I would get 6 plus 4, which is 10. And I would do the same thing for each of the other points that you have here, -1 plus 4. Wherever I see an x, I'm going to put in whatever the value is here. So negative and negative makes us +3 plus 4, which is 7. And then when I plugged in 0, which I love, 3 times 0 is 0. All I have is 4. If you would please press pause right now, and then fill in the blanks for 1 and 2, and then unpause when you're done. If you did that, then you would get these two numbers. Otherwise, you're just kind of a copycat and using my work. It's fine. Still love you. Maybe just a little bit less. So then you're going to graph each of these points. -2, and then you have to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Your next one is at -1, and then it goes up 1, 2, 3, 4, 5, 6, 7. And then you have 0, 4. And then you have 1, 1, and 2, -2. Here's what I don't want you to do. I don't want you to connect these dots because the given domain was -2, -1, 0, 1, 2. That's like if I ask you a question that's a yes or no question. All I want to know is yes or no, and yes or no. I don't want to know every detail. So if I say, am I going to see you in class on Friday? Yes or no? Not, well, we'll see because blah, 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 and then maybe blah, blah, blah. Just yes or no. Just cut to the chase. So I don't want any of the information in between that. I only want to know these specific points only. The other thing they asked me to do is to identify the range. Range is my output values or my y values. So for this one, my range is going to be 10, 7, 4, 1, and -2. Just as a list, and then you're good. All right, onward and upward. For your next one, you have y is equal to 1/3 x plus 2, and some of us will look at this 1/3 and will freak out, but I'm not going to because I like every single one of these numbers that's in my domain. Every single one of them. Because if I plug in -6, -3, 0, 3, and 6, I'm going to have friendly numbers because they're all multiples of 3. So y is equal to -6 times, just kidding. Probably I don't want to write this like this. Let's remix that. Y is equal to 1/3 times -6 plus 2. 1/3 of 6, well, let's put this over 1, and then some of us like to cross cancel, so 3 goes into 3 one time, 3 goes into 6 -2 times. 1 times -2 is -2 plus 2, which is 0. Do the same thing for the next point, y equals 1/3, and pretty soon, guess what I'm going to do? I'm going to leave this problem to you in just a moment. 1/3 of -3 is -1, plus 2 is 1. Then when I plug in 0, 1/3 times 0 is 0, so this is kind of like not here. 0 plus 2 is 2. If you're looking at this, you can kind of see a pattern, so pretend like you're plugging it in, and then check your work with mine if you don't believe me. Don't believe me, just ask. So then this will be 3 and 4. Again, plot these points, but don't connect your dots because I only want to know these specific values right here. Plot the points, but pretty please do not connect your points. Thanks. So next thing, I'm going to leave that to you. It will be a low graph, but I think you'll be fine with it. So go ahead and do that part on your own. I'll be looking for this part to be completed when I check your notes the next day. So the next thing I want you to do in number 3 is in 1920, the ratification of the 19th Amendment to the United States Constitution gave us women the right to vote. Thanks, guys. The table shows a number to the nearest million of votes cast in the presidential election, both before and since women were able to vote. So for the first value that they give us, years before, negative 12 years. So if it's negative 12 years, this would be 1908, because I'm just going to subtract 12 from 20. For negative 8, just to give you a reference, 8 minus 20 would be 1912. This would be 1916. At 0, it would be 1920. And so moving on, it's just going to increase every 4 years. Why? Because we only vote for presidents every 4 years. So for this, you have your values. In 1908, there were 15 million voters. 15 million voters in 1908. So next thing that they're telling us is explain how you know that this table represents a function. Well, if you remember from previous chapters, it's a function if every input has one output. That means that I can't say that in 1908 there were 15 million voters, and then later on my table it says in 1908 there was 29 million voters, for example. So as long as all of these are different, then it is a function. So I'm going to say, every input, which for us is the year, has a different output, which for us is number of voters. Graph the function represented by the table. So for this one, what I'm actually going to do is kind of just give you a couple of tips for this. And if you have a ruler, which I really hope that you do in your life, I don't actually, I'm just going to use a Post-it. Go ahead and draw your horizontal line here, and then just pretend like mine is really straight. I'm just using this with the, on this computer it kind of comes out a little bit crooked, but don't judge me. And then do your x-axis as well. And then I'm going to tell you how to set this up, and I'm going to let you graph it on your own because I realize you don't really need me for that. For your years, you're all good. I believe you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you can go by ones here. So 1, 2, 3. I would just probably, I'm only going to mark by 4s. So 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, negative 4. 1, 2, 3, 4. And we are in trouble because it does not actually fit. Burnt. So what we do is I would just probably take your lovely ruler, eraser, and switch that up just a little bit. And what I mean by switch that up, I basically mean I don't want you to go by this value anymore because it does not fit. So I'm going to erase and erase, and I erased a little bit too much, but that's okay because that line was whack anyways. Did you guys learn a lesson? The lesson was don't do this in pen. Use a pencil. See there, you thought I messed up, but nope, I was teaching you a lesson. So instead, I'm going to encourage you to go by 2s instead. So this will be 2, and then this will be 4, 5, this would be 8, 10, and 12. That'll make your life a little bit easier. Now, I'll also tell you, you will not have enough room to go all the way up here to 40, obviously. So let's count how many lines we do have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Ooh, barely makes 20. So because I know my biggest number is 40, I'm just going to go by 20s for this one. And then for 12, I'm going to go all the way up. And then that'll be my value. So you won't have the exact numbers for 37 and 29 because they're odd. But if I was going to do